There is a question that people have been asking themselves for decades, not in laboratories, not in universities, at kitchen tables, on rainy nights, after a glass of wine. The question is this: if you could go back in time, would you? Most people say yes. They would change something, a word they should not have said, a decision that went wrong, a person they did not call in time. It is a very human instinct. We want to fix what was broken. But here is the problem, and it is a serious problem, not one of philosophy or opinion, but of pure physics. Richard Feynman, one of the men who most deeply understood how the universe works, spent years playing with the equations of time, finding the gaps, pulling at the loose threads. And what he found was not a door left slightly open. It was a wall built by the very logic of reality. And the most devastating argument of all does not come from particle physics or relativity or quantum mechanics. It comes from a story so simple that anyone can understand it, and so destructive that no equation can survive it. It is called the grandfather paradox. And in the next few minutes, it is going to show you that time travel is not just difficult. It is impossible in a much deeper sense than you imagine. Stay, because this gets complicated in ways you do not expect. Let us begin at the beginning, not with the paradox yet. First, you need to understand what kind of thing time is, because most of us assume that time is something obvious. It passes, it flows, it moves forward. Each moment becomes the next, and the previous moments disappear somewhere behind us. Feynman never trusted obvious things. That was his first rule. If something seems too natural, too evident, you are probably looking at the surface of something much stranger. And time is exactly that, the surface of something much stranger. Think about this. The fundamental equations of physics, the ones that describe how atoms move, how particles interact, how gravity behaves, are completely symmetric with respect to time. Forward or backward, the mathematics does not distinguish. If you film a billiard ball hitting another and play the video in reverse, the motion looks perfectly natural. There is no law that says atoms cannot move in the opposite direction. So, if the laws allow time backward, why do we never see it? Because of entropy, because of the second law of thermodynamics. The sheriff of the universe, as someone who thought like Feynman would call it. Entropy says that systems go from order to disorder, that smoke does not gather itself back into a cigarette, that broken glasses do not reassemble, that heat disperses, never concentrates by its own will. And this is important because it gives us the arrow of time, the direction in which the universe seems to move naturally, from an ordered past toward a disordered future. But careful, this is only a statistical bias, a preference of the universe, not an absolute prohibition. And here is where the grandfather paradox enters the scene with all its brutality. Imagine that someone builds a time machine. Do not worry about how it works yet. Just accept the premise for a moment, the same way you would accept the rules of a chess game without asking why the knight moves in an L. You have a machine. You can travel to the past. And you decide to go back, very far back. To the year when your grandfather was young, before he met your grandmother. You arrive, you see your grandfather, and, for whatever reason, you kill him, before he has children, before your father is born, before you exist. What happens? Your father is never born. You are never born. And if you are never born, you never build the time machine, or never use it, or never make that decision. Which means your grandfather survives, which means your father is born, which means you are born, which means you travel back, which means you kill your grandfather, which means you are never born, which means you see it. It is a loop, a perfect circle of contradictions that destroy themselves. Feynman had a way of describing this type of situation. He said that nature is consistent. It can be strange. It can be quantum. It can behave in ways that absolutely violate your intuition, but it does not contradict itself. A fact cannot be true and false at the same time in the same universe. The grandfather paradox is not a philosophical eccentricity. It is a logical short circuit. And nature, unlike Hollywood, does not allow short circuits. But here is the part that most people do not consider, the part that goes beyond the mere killing of a relative. Some physicists, when they hear the grandfather paradox, respond like this: there is no problem. The time traveler simply cannot kill his grandfather. Something will prevent him. The gun will fail. He will slip at the critical moment. Someone will interrupt him. This answer has a name. It is called the chronology protection conjecture, and it was proposed by Stephen Hawking. The idea is that the universe actively conspires to protect its own consistency, that if you try to do something that would create a paradox, the universe prevents you in some way. It is an elegant idea, and it is completely unsatisfying. Why? Because it turns the universe into something that makes decisions, into something that knows what you are going to try and blocks it preventively. And that raises a much deeper question. How does the universe know what you are going to try before you try it? How can it protect the future from the past if time travel is possible? You are creating a solution that contains exactly the same problem it was trying to solve. Feynman distrusted this type of solution. He called them explanations by decree, saying that something cannot happen because the universe does not allow. It explains nothing. It only postpones the problem and hides it behind a nice word. We have to go deeper. Let us think about causality. This is a real prohibition, not just statistical. Causality says that causes precede effects, that the match is lit before the fire appears, that the glass falls before it breaks. That information travels from the past to the future, never the other way around. All the physics we know is built on this principle. Electromagnetic fields propagate forward in time. Gravitational waves travel toward the future. Information, any type of information, moves from before to after. Why does this matter? Because travel to the past does not only violate entropy, it violates causality. And violating causality is not like breaking a traffic rule. It is like trying to speak a language and having the words arrive before you pronounce them. Think about this. If you can travel to the past, you can carry information to the past. You can tell someone what is going to happen before it happens. You can warn yourself about a catastrophe that has not yet occurred. That means that the effect, the knowledge of the catastrophe, precedes the cause, the catastrophe itself. And when that happens, the logic of the universe completely falls apart. Not in a dramatic way, not with explosions. It simply becomes incoherent. Like a book in which the last chapter explains the first, but the first cannot exist without the last. Do you see the problem? It is not that it is difficult. It is that the very structure of the language with which we describe reality, cause, and effect, before and after, collapses. And here is where Feynman would have pointed out something that very few people mention, something that makes the paradox even deeper. You do not need to kill your grandfather to destroy the logic of time. You only need to exist in the past. Think about it. If you travel to the year when your grandfather was young, your physical presence at that moment alters that moment, not necessarily in a dramatic way. Maybe you just breathe a bit of air that otherwise would have been breathed by other molecules. Maybe your shoes leave a mark on the ground. Maybe someone sees you from far away and that changes what they think for 2 seconds. That is enough. In complex systems, like any system that involves human beings, small alterations are amplified in unpredictable ways. A meteorologist would call it the butterfly effect. A butterfly flaps its wings in Brazil, and, weeks later, there is a tornado in Texas. Chaotic systems are absurdly sensitive to initial conditions. Your presence in the past, even if only for an instant, even if you do absolutely nothing, alters the course of events enough for the future you remember, the future you came from, not to exist exactly as it existed, which means that you, as you are, cannot exist in that altered future, which means you never traveled to the past, which means the past was not altered, which means the future you remember does exist, which means you did travel, the loop again, always the same loop. Some physicists, at this point, propose an escape that seems intelligent at first glance, parallel universes. The idea is the following: when you travel to the past, you do not travel to your own past. You create a branching, a new universe, identical to yours up to that moment, which now takes a different path. You kill your grandfather in that alternate universe. In that universe, you are never born. But that does not matter because you come from the original universe, which remains intact. No paradox, no loop, problem solved. Except that it is not solved, it is evaded. This solution assumes something for which we have no evidence that it is true, that parallel universes exist and that time travel generates them automatically. It is not an explanation. It is a linguistic trap disguised as an explanation. Feynman had a rule for this type of reasoning. He said that if your theory requires you to add elements that you cannot observe or measure in order to avoid a contradiction, your theory is probably wrong. Parallel universes may exist, maybe yes, maybe no, but invoking them to save time travel is exactly the type of trick that an honest physicist should not play on himself. You are not solving the problem. You are redecorating the wall that hides it. But let us leave the logical paradoxes for a moment, because there is another level of the problem, a more physical, more mathematical one, and that, by itself, would already be enough to close the discussion. To travel to the past, according to what we understand from special relativity, you would have to move faster than the speed of light. The speed of light is approximately 186,000 miles per second. It is the cosmic speed limit, the strictest that exists. Not because someone decided it arbitrarily, but because it is sewn into the structure of space-time. Einstein showed that when an object with mass moves faster, it needs more energy to continue accelerating. And that relationship is not linear. As you approach the speed of light, the required energy shoots toward infinity. To reach exactly the speed of light, you would need an infinite amount of energy, not much, not all the energy of the sun. Infinite, a number with no ceiling. And to go faster than light, you would need more than infinity, which is not just difficult, it has no physical meaning. Put another way, it is not that we have not yet built a sufficiently powerful engine, it is that the universe does not have enough fuel to make that speed possible. The entire universe, all its accumulated energy, is not enough. And this matters directly for travel to the past because, in relativistic terms, surpassing the speed of light is equivalent to moving backward in time. The two problems are the same prohibition seen from different angles, the same wall, built twice. There is something that Feynman valued above almost everything: intellectual honesty, not with others, but with oneself. He said that the first question you must ask yourself when you have a theory is this: what evidence would make this theory false? If you cannot answer that question, if you cannot imagine any experiment that could prove that you are wrong, then you do not have a scientific theory. You have a belief. Travel to the past is exactly that. Not because it is impossible to imagine, but because any evidence against it can always be dodged by appealing to parallel universes, to chronology protection, to ad hoc mechanisms that cannot be verified. And when that happens, when an idea can survive any evidence against it, that idea has stopped being physics. It has entered another territory. Feynman had great respect for imagination. It was one of his engines. But he also knew that imagination without discipline is not science. It is speculation. And there is an enormous difference between the two. The grandfather paradox is not just a fun riddle for Sunday afternoons. It is a symptom that travel to the past is incompatible with the most fundamental structures of the reality we know: causality, entropy, the limit of the speed of light, logical consistency. They all point in the same direction, not toward a closed door, toward the absence of a door. So, what are we left with? We are left with something that, if you think about it carefully, is stranger and more beautiful than any time machine. We are left with the fact that the present is the only reality that exists, not as cheap consolation, but as a physical consequence of everything we have seen. The past is not a place you can return to because it is not a place. It is a configuration of matter and energy that no longer exists in that form. It has dissolved into entropy, it has dispersed, it has become something else. The moment when you decided something important in your life, the moment when you said something you wish you had not said, the moment when you did not call when you should have called, those moments are now part of the structure of the universe in a very deep sense. They are not stored anywhere that can be accessed. They are encoded in the current state of everything that exists. And that, even if it sounds like loss, is also a form of permanence. Feynman expressed it in a way that has something poetic without intending to. He said that the atoms of which we are made have existed for billions of years. They have been part of stars, of planets, of oceans, of other living beings. And when we die, they will continue to exist in other forms. We are borrowed from the universe and we return it when we are finished. Time does not travel. Time simply is. And we are, for an extremely brief instant on the cosmic scale, the way the universe observes itself. That is not consolation. It is literally what physics says. So the next time someone asks you if you believe in time travel, you can answer this. It depends on what you call time and what you call travel. Traveling to the future, to a certain extent, is possible. If you move very fast or place yourself near an intense gravitational field, Your time slows down relative to that of others. When you return, you have traveled toward their future. GPS satellites have to correct this effect constantly, or the maps on your phone would drift miles per day. But to the past, no. Not because we have not tried hard enough, but because the very logic of the universe, the way causality sustains reality, leaves no gap through which to pass. Feynman used to say that nature cannot be deceived. You can ignore its rules in your imagination, in your novels, in your movies, but nature continues doing what it does, with perfect indifference to your desires. And perhaps the most important lesson of the grandfather paradox is not that time travel is impossible. It is that reality has a structure, an internal coherence, that the things that happen in a way that makes sense within the broader framework of what exists. It is not a cage. It is an architecture. And understanding that architecture, even if it leaves you without a time machine, leaves you with something more valuable, the capacity to see the universe as it really is, not as we want it to be. That was what Feynman was looking for. Not comfortable answers, true answers. And in that, at least, we can follow his example.